Hi, thank you guys so much for sticking around for my talk. I know we're toward the end of the second day, so I really appreciate I'm not just speaking to myself up here. I'll introduce myself. I'm Kelcey Jasen. I'm a lead data scientist at MATCHESFASHIon. I've been there for a year and a half now. Previous to Matches, I was working at a prop tech startup trying to predict people, like what kind of properties they wanted to move into. And then previous to that, I taught statistics at a very large university in the United States. So that will come in handy for my talk and the methods that I'm going to discuss today. So despite my accent, I work for a London company. We are based in the Shard. Raise your hand if you've ever heard of MATCHESFASHIon. And then put your hand down if you're my colleague. Okay, so about 2 people, cool. We're a website mostly. Please go onto our website, look at the really cool fashion on there, look at the ridiculous stuff that Balenciaga tries to sell people for thousands of pounds and does sell to people for thousands of pounds. Download our app. But basically, MATCHESFASHIon, we've been around since 1987. That's when we first opened up our stores in London. And then we moved to e-commerce in 2007. And most of our business now is in e-commerce. So most of our sales are online. And we sell luxury fashion. So we sell Prada, Gucci, Balenciaga. Basically, I say we sell a bunch of brands I can't pronounce and at price points I can't afford. But it's very cool to work with, very fun data to work with, and very fun to just see what our customers are trying to do and try to predict their brains. So I'm going to be talking about customer lifetime value. And the reason we came up with this project about a year ago to focus on is because our CEO kept saying to put customers at the heart of all of our thinking. And so I think this project really touches a lot of aspects of the business because it tells us who are the customers that we should be focusing on because they're going to be driving the most value to us. And it uses their past behaviors to try to make predictions about what they're going to do in the future. So we're learning and we're reacting to what they've done, how they're interacting with us, what they're spending, and then trying to focus on the ones that are quite valuable. So I will talk about a few examples of how it touches our business. But before I do that, how many people have built an LTV model before? Oh, 2, 3, cool. How many plan to build an LTV model maybe in the next year or so? Yeah, a few. Okay, cool. So I'll talk about how I think the LTV model at MATCHESFASHIon is touching our business. Hopefully, even if you're in a different sector, it kind of translates to how it might affect your business as well. But if I talk about products, so the way MATCHESFASHIon works is we buy products from other brands. So Gucci has a new line coming out. We hand select which products we want to buy. We don't buy all of them. We curate it. And so we might be looking at our customer lifetime value to see, okay, how much do we predict our customers are going to spend in the next year? Can that inform the price points that we're buying the products at? So that's one aspect of it. Also service, customer lifetime value should be like the maximum amount you're spending on a customer to acquire it or to retain it. So if we know how much they're going to be spending the next year, we can also make some business decisions on how much we're willing to nurture that relationship. We offer a lot of like personalized experiences to our customers. We do events all around the world, so we spend a lot of money on customers that are very valuable to us. Are we spending too much money if we're not seeing that return on investment? So we can use LTV to help guide those types of decisions as well. And then lastly, our loyalty program I've alluded to. We really want to nurture the customers that are the highest value to us. So we might be sending them gifts. We might want to just make sure that they have like a private shopper or someone to like guide them along their path and try to push the sales up earlier in their customer journey. We can do that by identifying which customers are really valuable. Or looking at the other end of the spectrum, those customers that have the potential to churn. So Anis from Denham did a great talk yesterday on churn. He built a machine learning model for that. I also have churn as a subset of customer LTV, and so this is another approach to quantifying that prediction that they might no longer be with you. So our process, or what I decided to do, was buy Til You Die models. And buy Til You Die models, the name of that comes from the topic of survival analysis, which comes from biostatistics. So when people are doing drug trials and there's the possibility of dying. So in our case of shopping, a customer dying just means they no longer shop with us. It's nothing as dramatic as that, but that is the name in the literature. And what this whole family of models does is it just assumes probability distributions on certain customer behaviors. So how frequency that they shop or the metrics that I'll cover, it assigns statistical probability distributions to those decay rates. And we have to do that in our line of business as an e-commerce because we don't observe a flag when the customer churns. We're a non-contractual business. We're not subscription-based. So we're not like a Netflix where they see you've canceled your account. We don't really know when a customer has turned off from us or something that's happened to them. So we have to assume like these decay rates, which is what the probability distributions are doing. And I think these models have a lot of benefits to them as well. It is a simpler approach, so it's really easy for its explainability and interpretability to the rest of the business. Because it's based on really simple metrics, I can pretty much explain to someone else in the business that's non-technical about why that customer has that prediction. It comes from these certain fields that are really simple to understand. So sometimes the easiest route is the best route. This is also a long-standing method. And so that's why we went with Til You Die models. It's not because I'm an expert in men ghosting me. It's just the reasons that I mentioned. So I have 5 customers here. I have their transactions over time represented by a bubble. And then the size of the bubble is the amount that they spent at that transaction. So these are the main characteristics that go into the Til You Die models. And this is just it represented visually. So I'm going to show you the answers in a few minutes. But if you think about looking at it visually, could you figure out which customer is the highest value or likely to be the highest value in the next year? And could you figure out confidently which one is the lowest value? So think about it, because I'll tell you the answers in a minute. But these metrics visually get quantified and then go into the Til You Die models. So looking at the data numerically, it's a really simple data structure. You just take the sales data of your customers and you calculate basically 4 different metrics from it. So you calculate the recency, which is the number of days between their first purchase and their last purchase, their most recent purchase. You calculate the frequency, which is the number of purchases they made after their first purchase. So the number of purchases they made in the history minus 1. T, the number of days between the first purchase and really the time you're doing the analysis or the last sales date you have in your data, but that's usually for us the time we're doing the analysis because we have sales every day. And then lastly, the monetary value, which is just the spend that they have. So it's a really simple data structure. It's usually abbreviated with the acronym RFM. I don't know why T loses its value and its meaning in the acronym, but it does. And the more longitudinal data you have, the stronger your predictions are going to be. So hopefully, if you plan to apply these methods in your business, you have at least 1, 2, 3 sales per customers. The less data you have, the more sparse your data have, then the less accurate your predictions will be. Luckily for us, working in e-commerce, we have lots of sales, so this model has been a good fit for us so far. I'll look at one specific example to show you how to calculate those quantities. So one of the customers in the previous image, if I take them starting off and I just enumerate each one of their dots, then you can see recency is the time span between their first purchase, which was about April 19th to June 3rd. So recency becomes 410. Frequency is 11 because really it's the number of transactions after the first one. So it's 12 minus 1, 11. And then T, there was 632 days between their first order and the time that I did this analysis way back when, January 11th, 2022. And in these metrics, the most important one is really recency. That's the one that's going to affect most of all our customer predictions, but they all kind of go into it together, and then they have relationships with each other as well. So to look at those relationships between just 2 of them, which is probably a simpler starting point, if we think about recency on the x-axis and frequency on the y-axis, obviously it's desirable to have customers who have really high frequency and really high recency. So they shop a lot with us, and their entire history with us has been a long time. So that would be the upper right quadrant. Those are the highest value customers, and then it would tear down as you go toward the origin point. So when it comes to our application at MATCHESFASHION, we don't really care at the end of the day if I make a prediction that a customer is going to spend $15K with us over the next year, or if they're going to spend $14,999K. It doesn't really make a difference. So it's the exact specificity of the prediction. So we end up actually banding our predictions and looking at them in these types of tiers. Are they high value? Are they medium value? Are they low value? How can we bucket them and then kind of look at customers and cohorts of their predicted monetary spend? If you really, really care about accuracy, you might use other types of models. But for the sakes of our use cases, it doesn't really matter that we're down to the pound or the pence or the dollar. So it's not just this linear relationship between these two metrics. It becomes, like I said, that statistical probability distribution relationships between all the metrics that I just went over. So there's about, I think probably about 5 different buy till you die models. We started off at MATCHESFASHIon doing 2 of them. The first one we did is the Pareto and BD model, which that's Vilfredo Pareto on the left. Sorry if I butchered my Italian. He's an Italian physicist type of person, and that's one of the distributions that's in that name. And he invented, or this model was invented, he didn't invent it. This model was invented in 1987, so it's been around for 35 years. It's pretty much the gold standard when it comes to customer lifetime value models. Then Peter Fader on the right, he's an American economist. He came into the picture, and he built the BG NBD model, where all these letters just stand for statistical probability distributions. He has a really good talk on YouTube that I like, that he tries to explain. He spent 10 years trying to beat the buy till you die models with machine learning and data science, and he couldn't do it. So he finally joined forces and just improved it a little bit by doing a couple other probability distributions. So these models, I can talk to you more. I didn't want to get too technical, but I can talk to you more afterward if you're interested in hearing more about them. Just the methodology of it is, like I said, they're using probability distributions based on those customer behaviors. Once they're learned, you just predict the customer value after that. And if you are going to go and think, does this apply to your business? Does this apply to your sector? It's a really good idea to start by just visualizing some of those simple characteristics in your data. Look at, what's the distribution of the number of repeated purchases of my customers? And if it follows the distributions that are in these examples, if it follows the negative binomial distribution, like that sharp curve, then it makes sense that these applications and these problems would be used for your business. But if you think yours is a very rare case, you have very rare customers, that's just a good starting point to visualize it and get those sense checks that this is the right method for you. So if we did want to get really technical, we would go through pages and pages of the integrals that are behind these models. This is the Pareto NBD model, or one page of it. And looking at these equations definitely makes me nostalgic for when I taught statistics back in the day. But it also makes me very grateful that I'm now a data scientist and I don't have to do this. This translates into about 2 lines of code. So I've definitely joined the right career now. This is a Python example. I've also seen these models programmed in Excel. You can do them in Excel. You can do them in R. But at least the 2 that I'm covering today, they are both available in Python under the Lifetimes library. So of course, my notebooks are more than this in terms of the data prep and fitting the model and testing the model and doing the hyperparameter tuning. But really, at the end of the day, it comes to just using somebody else's package. So I showed you earlier these 5 customers. You can sense check if you were right. But really, the second customer would be the highest value in the next year to us. And then the 5th customer, the yellow one, would be the least valuable customer to us in our business in the next year, according to the data we have, and if things were to carry on, business as usual over the next year. So the point is it's hard to do visually. It's hard to do with your brain. It's important to look at these relationships and these decay rates with probability distributions and get the full picture using customer lifetime value. Was anybody right? Nerd. So how do we know this model's any good? All of these metrics, they're calculated based off of time series data. So a popular way to assess time series data is to look at a calibration period versus a holdout period. So I use a holdout period of 90 days. And then I basically pretend what if I look back 90 days, I look to see what the model would have predicted in those next 90 days, what would have happened, and I compare it to what actually happened in those 90 days, because I looked 90 days ago, so I know what actually happens. So I'm comparing the orange line with what the model predicted to the blue line, which is what actually happened, and you can see it's quite close, and it's quite close for a low amount of purchases, and then it starts having some divergence when you get into a large quantity of purchases. But that's more unrealistic for us, and we would have way less customers in that spectrum or in that side of the data anyway. So when we do have a larger error, it's because we have less customers. I could do a confidence interval around that, as other people have mentioned today. Don't really care to, because we're mostly focused on the lower end. That's not always good enough at MATCHESFASHION to just give our bosses and give stakeholders what the value of it is in terms of statistics and in terms of accuracy metrics. Instead, the business always likes to test things. So I'll talk to you about how we're testing this model at MATCHESFASHION. So one of our brands is Saint Laurent. And what we're doing is we're doing an A/B test where we send 2 different types of email campaigns based on different price points of the products of Saint Laurent. So Saint Laurent sells a scrunchie on our website for 125 pounds. They also sell a fur coat on our website for 12 grand. So we're taking the LTV model. We're saying those customers that have the capacity and the prediction to spend a high value amount, are they going to engage more in an email campaign where we are sending them the higher price points of Saint Laurent? And then those customers where we predict, they don't really have that capacity, they're a lower tier customer, they have a lower spend, are they going to engage more in the emails where they have the lower price points for that brand? So it's currently in testing, so I don't have any results really to show you, but that's one of the ideas we have, and you can imagine this being extended to personalization on the website. So if we know once you land, we have your cookies, we have your IP address, or you're logged in, we know who you are, we have your LTV, then we could personalize the homepage to products that are around the price points that are applicable for you. Another really easy way to execute LTV is in finding audience lookalikes. So Facebook allows you to upload your customer IDs, upload their predicted LTVs, and then they'll find lookalike audiences based on their data and what they know about customers who are similar to the ones you've said are your high LTV customers. You could also do exclusion groups with the low LTV types if you care to do that. We can also cut and slice this data with other things we know about our customers, like our acquisition channels. So let's try to look and see, are we acquiring really good customers from a certain region around the world at a certain acquisition channel? Should we be investing more into that or looking more into growing that capacity of the high net worth or the luxury customers? So as any data science project, this isn't over. It'll never be over. This, as I mentioned, has some limitations, and specifically these 2 models are limited because you need at least 2 transactions per customer. So the next round in the next sprints, we'll start applying some of the Buy Till You Die models where you only need 1 or less. This also, even though it's customer lifetime value, we don't do any computations to subtract like the acquisition cost, which could change by region. So acquiring a customer in the US might be different to us than acquiring a customer in Asia. So it doesn't factor any of that in, or the retention costs or anything like that. It also, it only includes those metrics. It doesn't include any other covariates, like what brands are they buying, what device did they come in on, like what's their gender, nothing like that. But there are other models in both the Buy Till You Die space and the machine learning space that would allow you to include covariates to capture that type of information. And then lastly, I anticipated somebody would ask about seasonality. Seasonality can also be a concern, being that we are in the luxury retail business. We have certain calendars, certain business decisions that might impact, what the customers will do. So I think that's it for my talk. Thank you for your time.